Good morning to one and all present over here. My name is Sai Kumar. I am from RMD Engineering College EEE department, and I am here to present how to perform the conversion of a number systems from one number system to another number system. In the last class, we were dealing with what are the different types of number systems, what were the digits supported by the number systems, what were the various parameters associated with the number systems. All these we had an elaborate explanation. Now we will be seeing how to use those concepts and how to perform the interconversion between the two number systems. With this basic introduction, let me go into my video. Okay, so the first number system conversion which we are going to see it now is the decimal to other number system conversion. Why we are going like this way, other number system? Because from decimal, I can convert to a number system of any radix or any base. There is no any hard and fast rule that I must convert decimal number system only to a binary number system, decimal number system only to a hexadecimal number system. There are several number systems to which I can convert. But before going into these conversions, I must tell you the name of the number system so that you'll be having a correlation about what is the purpose of this interconversion. So base 2 number systems are generally called as a binary number system, and the characters are range they support is 0 and 1. And because 2 digits are supported, the radix is 2. Next, we are having a ternary number system, base 3. It supports totally 3 digits, 0, 1, and 2. So since 3 digits are supported by this particular number system, the radix is 3. Quaternary number system, yeah, there are totally 4 digits over here, 0, 1, 2, 3 over here. And since there are 4 digits supported over here, the base of the number system is 4. Similar is the case for other number systems. The number of digits determine the base. So let us first go how to convert the decimal to other number system conversion. For this purpose, we must know what, how is generally a number is considered. A general number is always a rational number. It has both integer part and fractional part. Generally, a number, if it is going to, we are going to say a number, it refers to a rational number only. A rational number means it will be both having a non-fractional part as well as a fractional part. The non-fractional part, it is also called as your integer part, and the number which is after the radix point, that is called as your fractional part. So here, let us go with this particular example in order to teach you this 450.2698 to the base 10. First, let us confirm whether this number belongs to a decimal number system or not. So as far as your decimal number system is concerned, what are the set of digits if you see means 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So all the numbers which are present within this, all the digits which are present within this number system, they conform to the digits present in a decimal number system. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So since it is all the digits conform to the decimal number system, we are confirming it to be a decimal number. Okay. It is having 2 points. One is called as your integer part, which is nothing but 450, which is before the decimal point. And another one is 2698, which is after the decimal point. Now what they ask, convert this particular decimal number into an equivalent binary number. This you might have studied in your earlier 10th or 12th or any other sections. This is very, very easy. We'll be going with the long division method. So what is the basic concept behind this conversion? If you see means, if you are going to have an integer part means you must progressively divide that part by the base of the number system to which you want to convert till the quotient part becomes 0. So maybe it may be mind-boggling for you. Let me show you. For example, I want to convert this number into a binary number over here. It is having both integer part as well as fractional part. It is separated by means of a decimal point over here. So first, let me convert this integer part into an equivalent binary number. Then I'll be converting the fractional part into an equivalent binary number. Then I'll be concatenating both. So let's go with this. First, 450. I'm going to progressively divide 450 by 2. For each division, I'll be noting down the quotient and I'll be noting down the remainder. I'll be noting down the quotient and I'll be noting down the remainder. Once the quotient part becomes 0, I'll be grouping all the remainders starting from bottom to top. Okay, let us go. So 450 divided by 2 will be giving me 225 and the remainder is 0 because 225 into 2 is 450 and the remainder is 0. Next, I'm going to divide 220 divided by 2. So the nearest number for 225 is less than or equal to 225 if you see means the number nearest to 225 but not greater than 225. Kindly understand. For example, 226 is also there, 113. You must always take a number which is less than or equal to the given number. So 225, the number nearest to 225, but also divisible by 2 if you see means 224, which is obtained by multiplying 112 into 2. So I'm getting 112. The remainder is 1 over here because 225 minus 224 is nothing but the remainder is equivalent to 1. Next, I'm going with 112. When I'm dividing it by 2, I'm getting 56. The remainder is 0. 56, when I'm dividing it by 2, I'm getting the quotient to be 28. The remainder is 0. And when I'm dividing 28 by 2, the quotient is 14. The remainder is 0. And when the dividing 14 by 2, I'm getting 7 as the remainder. Quotient is 0. When I'm dividing 7 by 2, the quotient is 3. Remainder is 1 because 2 into 3 is 6. 7 minus 6 is equivalent to 1. When I'm dividing 3 divided by 2, the quotient is 1. Remainder is also 1. And finally, when I'm dividing 1 by 2, it is not divisible. So I'm multiplying the quotient by 2. So quotient by 0. So 2 into 0 is 0. So 1 minus 0 is 1. So since the quotient has become 0 over here, I'm stopping the division operation and I'm grouping the remainders from the bottom to top. So what will be the equivalent value? 1, 1, 1, 0, 0, 0, 0, 1, 0. So this is the way how do we convert an integer part of a decimal number system into a desired other number system value. Now I need to convert the fractional part into an equivalent binary value. For this, just the opposite of division, multiplication. We need to progressively multiply the given fractional number by 2. For each multiplication, you will be getting one product. That product will be in turn having an integer part and fractional part. From that product, you have to segregate the fractional integer parts alone and group it under a particular name. Kindly understand, we need to progressively multiply a fractional part by 2. For each multiplication, we'll be getting one number. That number will be having a fractional part, an integer part. Segregate the integer part alone and keep it separated. Then you need to group all the integer parts alone from top to bottom. Okay, let us see how it is possible. 0.2698 into 2 is nothing but equivalent to 0.5396. So in this 5396 is your fractional part and 0 is the integer part. So take out the 0. Next, 0.5396 into 2, I'm getting 1.0792. In this, 1 is your integer part, 0.0792 is your fractional part. So keep the 1, segregate 1 from this product. Next, 0.07, you have to multiply only, you have to take each and every time, you have to consider only the fractional part of the product for the subsequent multiplication. You must not take the entire product. Okay. Here 1.079 means I'm going to take only 0.0792 for the subsequent multiplication. I will not be taking 1.0792 for my subsequent multiplication. So 0.0792 into 2 is 0.1584. So here the integer part is 0. So I'm segregating it. Then 0.1584 into 2 is 0.3168. Here the integer part is 0. Since the multiplication, it is going to keep on continuing without the fractional part is becoming 0. I'm stopping at a convenient point. Actually, what is the concept of this? I have to keep on multiplying by the base of a number system to which I want to convert till the fractional part of the product becomes 0. But here in my case, I'm getting zeros or ones in the integer part, but I'm not getting it in the fractional part. So I cannot keep on continuing my multiplication operation because it is a laborious process. So I need to stop myself at a convenient point. I'm just taking 4 steps for my multiplication and I'm stopping it. So I'm stopping it over here and I'm grouping all the integer parts, what I have segregated from the product from top to bottom fashion. So 0, 1, 0, 0. So this is my equivalent binary number for my fractional part. So the entire binary number for the decimal number 450.2698 to the base 10 is nothing but equivalent to 111000010 dot 0100. So this is the way how to perform a conversion of your decimal to binary number system. So thank you for allocating your time, and thank you.